Hi Pre-Calc. Today we're going to do exponential functions and their graphs. As you can see here, the definition of an exponential function, it has a base a where a is greater than 0 and a does not equal to 1, and it's a real number, okay? Exponential functions are really simple looking functions, but they are some of the fastest growing functions in mathematics. So they are sort of like, they look deceptively simple, but they grow extraordinarily fast. They're some, like I just said, they're some of the fastest growing functions in mathematics. Now, when you first see this, it's really important that you register the difference between 2 to the x versus x squared. What we did in the past was x squared. This is a parabola. 2 to the x is an exponential function. What makes an exponential function is that the variable is up in the air. The variable is not the base. The variable is up in the air. That makes an exponential function. So I'm going to start this lecture by with graphing. Okay, so let's start with this function here, 2 to the x. I'm going to plug in these x values into this function. So 2 to the negative 1, that means I have to reciprocate it, which makes it 1/2. Remember, a negative exponent means you have to flip it. 2 to the 0, anything to the 0 is 1. 2 to the 1 is 2, and 2 squared is 4. Okay, so I just picked some values there, and I'm now going to graph that. And the other thing I want to point out is for a standard exponential function, it has a horizontal asymptote at y equals to 0. Okay, I need you to memorize that. If you have a standard exponential function, it has a horizontal asymptote at 0. Okay, I'm going to plot these points. So negative 1 is a half, 0 is 1, 1 we're at 2, and 2 we're at 4. Now, the horizontal asymptote, that means that on the left side of this graph, it's going to want to ride. It's going to ride right above the horizontal asymptote, and then it's just like lift off. Lift off. It's off and running. Okay, so this is your y equals 2 to the x. So it's going to ride the horizontal asymptote on this side. It doesn't go through it. It doesn't cross it. It stays right above it. Okay, so now this is the same graph, but I've added 1. And if you remember, just like with parabolas or other graphs, you got to recognize the difference between when you put something in the function or something after the function. This is after the function. And when you put something after the function, that's what moves it up, down. So because this has a horizontal asymptote, you can also push HA up and down. So if you see a big number after the after the exponential function, that's going to be your horizontal asymptote. So I can tell right away, because this is pushed up 1 unit, that HA is going to move from 0 to 1. So basically the floor of this function has moved up from a 0 to a 1. Okay, now we're going to plug in these values so you can see it again. All right, 2 to the minus 1 again is a half, so a half plus 1 is 3 halves. 2 to the 0 is 1, 1 plus 1 is 2. 2 to the 1 is 2, so 2 plus 1 is 3. 2 squared is 4, plus 1 is 5. Okay, so at negative 1 I'm at 3 halves, which is 1 1/2. At 0 I'm at 2. At 1 I'm at 3. At 2 I'm at 5. 2, 3, 4. At 2 I'm at 5. Okay, so you should be able to see that all these output values here are 1 unit higher than the previous one because we've taken all the y values and made them 1 higher. Again, don't cross the floor. It's a new floor, right? So the HA, you just write it. It's an asymptote. You're going to just write it on the left side, and then the function takes off. This, by the way, is what we would call exponential growth. An example of exponential growth is if you have a population and if it has all the resources it would ever dream of, unlimited food supply, whatever it needs, it will grow exponentially. So population is an example of that. Bacteria population is also an example of that. Okay, gang, so let's try another one. All right, now notice the difference between the one we just did and this one. You see now this is in where the exponent used to be, right? The exponent used to be here is 2 to the x. So the x has become x plus 1. So x plus 1 is flying in the air. That's different than adding 1 on the end, okay? That's different than adding 1 on the end. If you add 1 on the end, you push the graph up. If you put 1 inside the function, that's your left-right switch. So this is going to move it left, right? It's always opposite of the inside. So this guy is actually going to end up going to the left. Okay, so I'll put in the numbers so you can see it. Okay, if we put in a -2, that's 2 to the -1, which is a half. Okay, this one's 2 to the 0, which is 1. 2 to the 1, which is 2. 2 to the 3, which is 8. Because 2 times 2 times 2. Alright, so I'll just keep repeating myself till it makes sense. But try to remember that the standard graph has a horizontal asymptote at 0. That floor can only move if you go up and down. If you go left or right, that doesn't change the height of the floor. So here when we go left, that doesn't change the height of the floor because we're not pushing the floor up or down. So it's going to stay where it is. What we are pushing is the function. We push the function to the left. Okay, at -2, I'm at a half. At -1, I'm at 1. At 0, I'm at 2. At 2, I'm at 8. 2. Let me put a 1 in here also. 1, 2 to the 1 plus 1 is 2 to the 2, which is 4. Okay, at 1, I'm at 4. Okay, you know what? I'm going to leave it at that. You can certainly do 2 to the 8 on your graph if you're doing this with me. Just that's enough points right there. All right, in general, if you're sort of like, okay, what is she going to want on the test? You want to know, I'm going to want the y-intercept. If it happens to cross the x, I want that. I haven't done any crossing the x yet. I'm going to want the y-intercept, a point to the left, a point to the right, and the HA. So at that point, at this point in the game, that's my expectation. The y-intercept, a point to the left, a point to the right, and the HA. That's what I'm going to ask you for right now. It's going to get a little more complicated once we can start solving these. I'm just going to do this briefly, rough sketch it, so you can see the gist. Just like a parabola, if you put a negative in front, it makes it frown. It's the same thing with an exponential. If you put a negative in front, it's going to flip it down over the y-axis. So this guy looks like this. Again, you didn't push it up or down, so it's still going to have that HA at 0. Okay, but this is going to flip it over the y. It's going to take this shape and flip it over the y. Okay, so a negative out front makes it sort of like frown. And a negative inside is going to flip it over the y. So this one flips over the x, the other one flips over the y. Again, you haven't pushed it up or down, so your HA is still, your horizontal asymptote is still y equals 0. But this guy, it went this way usually, but you're flipping it, so it's going to go this way, and I haven't gotten much into this one yet, but this is like, this is called exponential decay. An example of that is like if somebody buys a new car, let's say somebody buys a fancy new car, the minute they drive it, the second that they move it like 1 inch, it's used, right? And it drops like, if it's an expensive car, wow, it's going to drop thousands and thousands of value just in the first second you use it. Okay, gang, that's just my quick intro on graphing. At this point, we've done a lot of graphing, so you should recognize what goes up, what moves something up, down, what moves something left, right, how do you reflect something over the X or the Y. Okay, so these patterns keep reoccurring. You're just applying them to different shapes. All right, gang, I'll catch you in another video. Hope you enjoyed this. Bye-bye.